In this video, I'm going to talk about predict product worksheet 2, DD, meaning double displacement. So definitely you need the solubility rules. This is for double displacement. We need this chart. And then you will be provided this information on the test, okay, on the exam. But the bottom starting like this part, you will not be, you will be like, you need to know how to do that, okay? So you of course you need a color pen, and I will do the first 6 questions in the video. Okay, so in the previous worksheet we learned about how do I decide whether something is aqueous, whether something is solid, or whether something is precipitate. You need to know them again. Okay, and what happened to the double displacement? Okay, double displacement, we need to use solubility rules here. And double displacement is when you have two compound. Okay, let's say A, B, or C, D. And you know double displacement is always like compound plus compound to form compound and compound. So what happened is the A, B, and C, D, they're the compound, and they switch partner. So you can see that I have the A and D dancing together instead. Okay, and then B and C dancing together instead. Okay, so A and D go together, and B and C go together. And you notice that later on you will know that A and D, okay, A is positive, D is negative. So then that's why they can form a compound. And B is a positive, and C is a negative, so they can form another compound. Okay, so you have to switch the order like that. You cannot have A and C together, because A and C, they're both positive, they cannot form ionic compound. You cannot have B and C together because B and D are both negative, so they cannot form a compound. So it must be positive and negative, positive and negative. So A and D working together and B and C working together. And in order for double displacement to take place, okay, you have to have two conditions happen at the same time. Okay, so when the double displacement take place, you have to balance the equation. Right. So what are the two conditions? You have to have them at the same time in order for you to say the double displacement take place. Number one, both reactants are aqueous. Both reactants must be aqueous, and either gas. Number two, either gas or PPT or H2O liquid is produced. Okay, either gas or PPT or H2O liquid is produced. These two must be met at the same time. If only one of them working, then double displacement would not take place. Okay, so if you figure out that the double displacement takes place, you have to balance the equation. Okay, we will show you in a second. Now, how do I know double displacement doesn't take place? Okay, so when it doesn't take place, you would not need to balance the equation. Okay, so when either one or both reactants is or are not aqueous. So either one reactant is not aqueous or both reactants are not aqueous, then it doesn't take place. Or if no gas, no PPT, no water liquid is produced. Okay, either one of them, either A or B happen, then you will say that there's no reaction, then you don't have to balance the equation. So let's look up this. Okay, so on the worksheet, I will only give you the two reactant. And I would not give you the coefficient, I will not give you the product, and I will not give you the state. All I give you is AgNO3 and CuSO4. Okay, so you need to predict whether there's a reaction take place. If there doesn't reaction take place, what are the product, and then you finally balance. Okay, so what are the steps of how to get this completed? So first of all, step one, you have to identify if it's if the reaction is double displacement, because I give you like predict product, I give you combustion, I'll give you double displacement, I don't give you single displacement. You have to identify if they are double displacement. Well, how do I know that they're double displacement? If I just look at the first two reactant is the two reactant must be compound. If the two reactant are compound, but they are not CXHY, they are not O2, and they don't have element, then must be that they're compound, they're both compound, they must be double displacement. So you have to identify the two reactant is, are they compound? No CXHY, no O2. Okay, that's step one. And then step two, once you know that, okay, they are double displacement, you got to decide if the reactants are aqueous. Okay, if this reactant are aqueous, if this reactant are aqueous. So how do I know that? We go back to look up this. Okay, we look up the solubility rule. We say, oh, okay, the two reactants are aqueous, then we label aqueous, aqueous. That's step two. And then step 3, you want to underline and form back the positive and negative. Underline and form back positive and negative. So what happened is you had to underline them separately because you had to cross over back to form their own charges. So HgNO3, CuSO4, you underline them, and then you form you cross over to form the charge spec. So AgNO3, they form the charge spec crossover. You get Ag plus, NO3 minus, and then this is Cu2 plus, SO4 2 minus. I assume you know how to do the crossover. And please, there's one thing here. I want you to underline here is actually the first one. Okay, please make it red color. And the last one also make it red color. Okay, the first and the last make it red color. And then the middle two make it green color. The middle two make it green color. Okay, so the first and the last one red, number 2 and number 3 make it green color. Okay, so you cross over, you form the charges back. And then number 4, you want to draw the rainbow. So the first and the last one, we draw the rainbow using red color. The first and the last one, we draw the rainbow using red color. And the number 2 and number 3, we form the rainbow using green color. That means they got a switch, and then Ag and SO4 will combine, NO3 and Cu will combine. And then number 5, you want to put the positive and the negative into the clouds. Now of course we have rainbow in the reactant, of course we have cloud. And where are the clouds? The clouds are on the product. So you want to draw the cloud. So we have the Ag and SO4, we put it in the first cloud. Ag plus SO4, we have to put the first cloud. Okay? And then the Cu2 plus NO3 minus will be the second cloud. Now be careful here. Both clouds, you want to put positive first, negative next. So the first one, I don't think anybody will make a mistake. You just copy Ag plus SO4 2 minus. You have to put it in this order. But a lot of people go to the green cloud, they will forget it. They just forget to copy NO3 minus Cu2 plus. Put it on here, which is wrong because you have to follow positive first, negative next when you do crossover on the ionic. So be sure that you have to switch back positive first, negative next. So you draw the cloud back here. Okay, and then number 6, you form back the compound and they become product. So Ag1 plus SO4 2 minus, you cross over and then you put back here Ag2SO4 and then plus, and Cu2 plus NO3 minus, you cross over, you get Cu parenthesis NO3 2. That will be the compound for that step number 6. And then step number 7, states of the matter of the product. So again, when you get Ag2SO4, you go back to final solubility to decide that they are what state. So here I find their PPT. And then the CuNO3 I found out their aqueous. And then finally, that's number 7, okay? And number 8, if one of the product is PPT, like this one is PPT, or gas or water is produced, then you will say reaction take place. Okay, reaction take place. I'm going to put a check mark there. Then I will go ahead to balance the equation. I balance 2, 1, 2, 2, 1, 1, 1. Okay, if the gas and PPT and water is not produced, then will be no reaction take place, then will be no balancing. So I will show you the example. Okay, now here, those are the template. So this one is exactly what I just showed you. So I put a check mark in the arrow to show that reaction take place. And then the reason you have to provide the reason is number 1, both reactants are aqueous. So see, this reason is the same reason on here. Both reactant are aqueous. Okay, and then step 2, we say step 2, either gas or PPT or H2O is produced. So which one is the product that I decide to say that this is double displacement is the Ag2SO4. So you're going to write, oh, Ag2SO4 PPT is produced. If this is water, then you will say H2O liquid is produced. If this is gas, for example, H2 gas, then you will say H2 gas is produced. Okay, so these two reasons must be present at the same time for you to put a check mark for you to balance the equation by putting the coefficient. Okay, so let's look at the second reaction. Now, second reaction, you go ahead to draw the rainbow and then put the ions in the cloud. And then what happened is you find out that both of the product is aqueous. We don't have any gas or PPT or water. So in this case, I would just put an X, no reaction. I don't need to balance equation. Just put X under no reaction, no balancing. And the reason I have to write is no gas, PPT, H2O liquid is produced. That's the reason you need to write. Okay. And then the third one is I find out immediately. I don't even need to do any rainbow or cloud. Do you know why? Because I found out from the solubility rule, I found out that both the reactants are not aqueous. Both of the reactants are not aqueous. Remember I say aqueous, meaning that they can be dissolved in water. They will be soluble in water. That means they will be decomposed into positive charge and negative charge. If they are not aqueous, that means they're not soluble in water. If they're not soluble, they will just sit there and would not decompose. So then these two they would not form Bb2 plus and OH minus. They would not break down. So I cannot break it down. Then how can you exchange partner? Okay, the couple must be broken down first, and I can exchange partner. Since they are not aqueous, they are solid. Okay, they are solid. They are on the reactant. They are solid. So no reaction take place, so I put no reaction, and both reactants are not aqueous. And let's say number 4. Okay, this reactant is aqueous, I can break it down. But this reactant is not aqueous, so then will be also still no reaction. And I'm going to write one reactant, or which one? Oh, AgCl as is not aqueous. You have to tell me which reactant and the state. Okay, you cannot just say one reactant is not aqueous. Which one is talking about? You have to tell me which reactant and what's the state. Oh, it's a solid. You prove that it is not aqueous. Okay, so these are the examples that I gave you. So I'm going to jump to the worksheet directly. Okay, and the direction said that number 1, you want to complete the equation and balance them only if there's a reaction. Okay, so you balance them only if there's a reaction. Okay, if there's no reaction, you write no reaction. And then for either case, give me all the reason. Okay, so we need to identify what kind of reaction. Okay, you can see that KOH is a compound, HCl also is a compound, so this is a double displacement. Okay, because they're also compound. And then if they are double displacement, we can start to find the state. Okay, we want to find the state. So let's find the KOH first. So KOH is hydroxide. So we can read it. Hydroxide OH are soluble except those of group 1. Now K is group 1, so meaning that potassium hydroxide we have the exception. So potassium hydroxide, okay, OH, you're going to read it, OH are insoluble except those of group 1. Okay, potassium is group 1. So meaning that the potassium hydroxide is soluble. Potassium hydroxide is soluble because potassium group 1 is an exception. Exception will be opposite of insoluble. So potassium hydroxide is soluble. Potassium hydroxide is soluble. KOH is soluble. So we're going to write AQ. Okay, and the next is HCl, so chloride. Okay, so all chloride, are soluble. No exception here because no H here. So chloride are soluble. All chloride are soluble, then will be AQ. Okay, now since they're AQ, that means they are soluble, we can start to break them down. So I'm gonna underline the K, underline the HCl, and then the first and the last one with red pen. Okay, and then the blue pen will be the second and the third. Okay, now you do crossover yourself in your mind. Okay, so KOH, you crossover, I will have red pen K plus. Okay, and then OH minus. Okay, you break it down. Okay, so green, red, and green. And then here, if I break it down, I will have H plus, green pen, and then Cl minus. Okay, and then next, they're going to draw the rainbow. So I'm going to draw the rainbow with green pen for the 2 and 3. Okay, green pen for 2 and 3. And then red pen for 1 and 4. Like that. Okay, then we're going to draw the cloud. Okay, so I usually like to draw the red one first, but honestly, it doesn't matter. You can put the green first, you can put the red one first, but I honestly usually do the red one. But honestly, doesn't matter. So I'm going to bring that on here. So I'm going to bring the K plus and the CL minus onto the first cloud, okay, onto the first cloud, and I will circle that, okay, and then I have the second thing will be the H plus and OH minus. Now be careful here. I say always plus first, negative next when you do crossover, okay? When you do crossover, plus first, negative next. So here I'm going to put H plus and then OH minus on the green cloud, right? Then I can go back to do the crossover. I put a coefficient thing here. So KCl, when you cross over, you will get KCl, okay? And I leave the state open, okay? And then green pen plus, okay, plus I leave a coefficient, and then this crossover, I will get H2O. Now H2O here, okay, we always say that this is a liquid. H2O here, when they form, we always say liquid. Okay, like when you have the reaction take place, it always form liquid form. And then when they will form gases, like when you have the reaction, like hot enough and they become vapor. But we will not talk about that. We'll just talk about at the beginning of the reaction, water liquid is formed first. Okay, then we'll go back to check the solubility. Okay, KCl, chloride, we check solubility. Chloride are soluble. That's it. Okay, chloride are soluble. That means they're soluble, we're going to put AQ. Okay, and then water is always liquid. So here, do we need to balance equation? Yes, we do have to balance equation because based on the reaction, the condition, I have two things. Number one, both reactants are aqueous. See, both reactants are aqueous. And then number two, number two, H2O liquid is produced. Either one of them is fine. H2O is produced. Okay, so we got to write the reason. So we got to use black pen to write the reason. Okay, to write the reason. Black pen. So number one, both reactants are aqueous. Both reactants are aqueous. That's number one. And then number two, H2O liquid is produced. Okay, H2O liquid is produced. So number one, both reactants are aqueous. Number two, H2O liquid is produced. Based on these two, okay, we will say that we do have reaction. Put a check mark on the arrow. Then finally, we're going to balance them. So I assume you know how to balance the equation. The balancing thing will be 1, 1, 1, 1. 1, 1, 1, 1. Okay. Now let's look at the second one. K3PO4 and NaCl, they are both compound and there's no CXHY, there's no OH, no O2, and no element here, so it is double displacement. Okay, so we look up the K3PO4. Now K3PO4, we look up the phosphate. So phosphate are insoluble. Phosphate are insoluble except those of group 1. Okay, phosphate are insoluble except those of group 1. And K is group 1. So meaning that it is soluble. So we're going to put AQ. And then NaCl, okay, chloride are soluble. Chloride is soluble. So we also put AQ. Okay, so in this case, I can separate them. So underline this and this red pen. And then I underline the 2 and 3 with green pen. So we got to start to cross over. So I get K plus, and then I get PO3, parentheses 3 minus. Okay, and then the NaCl, I got the green pen, I get Na plus, and I got Cl minus. Okay, so the green pen, the 2 and 3, I'm going to draw the rainbow, meaning that they go together. And then the red pen, I'm going to draw them together. Okay, so look like this. Okay, so we bring them to the cloud. Okay, so we bring the red thing first. So K plus, and then Cl minus, bring them to the first cloud. And then the green pen will be Na plus, parentheses PO4 3 minus. Okay, we bring down the second cloud. Okay, now we go back to crossover. So KCl, we parentheses coefficient first, and then I can put KCL. All right, so the state, and then the second one, okay, I cross over, I got Na3PO4. Okay, now finally we check the state first. Okay, don't balance the equation. Don't balance the equation until you make sure that the conditions are matched. Okay, you may not need to balance the equation. So look up the KCL, look up from number one, it is AQ. Okay, now Na3PO4, so phosphate. Okay, phosphates are insoluble except those of group 1. Phosphate are insoluble except those group 1, and Na is group 1. So in other words, this is AQ. This is AQ. Okay, so in this case, should I balance the equation? Okay, you want to look up the reason thing. Okay, the reason thing is I do have both reactants aqueous, but I have the reason here. No gas, no PPT, no H2O liquid is produced. Okay, so I'm going to use green pen to write the reason. The reason that didn't match. So either A or B, you need to write. Either A or B. You see that I write either one of them. Okay, so here I'm using green pen. So no gas, PPT, H2O liquid is produced because my product does not have PPT. So in this case, I will put a X on it, no reaction, and in this case, you have no balancing. Just leave it like that. Okay. So number 3, this is a compound, no CSHY, no O2, so this is a double displacement. Okay, so when we found the solubility under the solubility is ZnOH2, so we're going to have to find that hydroxide. So hydroxide are insoluble, no exception. Okay, so insoluble, then this one will be solid. And then the K2S, K2S is sulfide. So if you go to find sulfide are insoluble except those of group 1. So that will be exception. Okay, because K is exception, group 1, so will be AQ. Okay, so when you read it on here, you don't even need to continue. Okay, you can just put no reaction here. Okay, the reason, what's the reason? The reason is I'm using this one. So it's not both reactants are aqueous. It's not both reactants are not aqueous. It's one of the reactant, or which one is ZnOH2 is not aqueous. So we're going to using blue pen to write one reactant. Or which one? Okay, Zn, when this is OH2, you also have to tell me that this is solid. You have to give me the state. Okay, so one reactant ZnO2 solid is not aqueous. Okay, so that's it. Okay, I can do 3 more questions for you. So I'm going to do 4, 5, and 6. So FES, if you find it, it is, first of all, this is a double displacement. Okay, so FES, sulfide are insoluble, no exception. So this will be solid. HgO, Hg2O is oxide, this is mercury 2 oxide. So oxide are insoluble, no exception. Okay, right here. So then you don't need to continue to write. You just say no reaction. But the reason is not one reactant, is both. So blue pen, both reactants are not aqueous. And that's it. Okay. So number 5. Okay, they are both compounds, so double displacement. So when I check the solubility, okay, so it's a hydride. Okay, so hydrides are soluble, no exception. So this is AQ. Okay, and then Br, bromide. So bromide are also aqueous. Bromide, aqueous. So then we can kind of like separate them. So Mg, Br, we separate them. And if you do the crossover in your mind, you know that this is Mg2+. And then this one is B minus. And then if you underline the H2 and the H, if you cross over, you know that this is H minus, this is H plus. Okay, so we draw the rainbow for the green, we draw the rainbow for the red. Okay, and then we bring the cloud, right? We bring the ions to the cloud. So we have the MG2 plus and Br minus in the red cloud first. Okay, so then we can go ahead to crossover. We get the coefficient and then MgBr2. And if I check the solubility, I know that this is aqueous. Okay, and then the next thing is the H minus, H plus. So we have to rearrange them. The plus go first. Plus go first. Okay, when we rearrange them, we find out this is H2. And H2, you know that H2 is diatomic, so it must be always gas. Okay, now you can see that with that, the double displacement take place. Yes, because number one, both reactants are aqueous. Yes, both reactants are aqueous. And then number two, I can have gas produced. My gas is H2. So this one reaction take place. So we got to write the reason. Okay, we got to write the reason. Number one, the black pen, okay, black pen. Number one, both reactants are aqueous. Okay, both reactants are aqueous. And then number two, I form my H2. Okay, H2 is a gas. H2 is a gas, is produced. Okay, so based on these two, reaction take place. So put a check mark on it, and then we got to balance them. The balance coefficient would be 1, 2, 1, 2. Okay, and finally I'm going to do one more. This number 6. This is double displacement. Okay, and CaNO3 2 is aqueous. HCl is also aqueous. Okay, so I'm going to underline Ca and I cross over. I know it's Ca2 plus, and then the underline the Cl, I know it's Cl minus, and then the I underline the NO3, I know it's parenthesis NO3 minus, and here I underline H will be H plus. So I rainbow the green and I rainbow the red. Okay, so rainbow. All right, and then I'm gonna go jump to the red rainbow. So Ca2 plus Cl minus in the red rainbow first. Cl2 plus Cl minus, and then they will form CaCl2, and I know that by checking solubility is AQ. And then the next cloud is again must be plus first, negative next. Okay, must be plus first, negative next. So I got H plus NO3 parenthesis minus. I draw the cloud, and when I cross over, I got HNO3, and I check the solubility type is aqueous. So then you can tell that actually no reaction because no gas PPT or H2 is produced. See, no PPT here. So then here I'm going to use the green color to write no gas, no PPT, and no H2O liquid is produced. Okay, so that means will be no reaction. And no reaction, you don't need to balance the equation.